One common task in natural language processing is figuring out which words are important and which words are less important. And one very common method of doing so is called tf-idf. Hi, my name is Eugene, and in this video we're going to introduce tf-idf, and we'll also write a program in Python that will read an email and find the most important words in that email. tf-idf consists of two parts, tf and idf. tf stands for term frequency. The more frequently we find a term in a document, the more important this term is. Let's take a look at an example. I have something called the pet sentiment corpus. In this corpus, people have expressed their feelings about common domestic pets. The corpus consists of two documents. Here is the first document, I love cats, and here is the second document, I love dogs. Let's compute the term frequency for each term in both of these documents. Term frequency is the number of occurrences of a particular term in a document divided by the number of words in that document. So for I love cats, the term frequency of I would be one occurrence, because the word I occurs only once, divided by the number of words in that document, which is 3. And it's the same for all of these. That's our term frequency. Let's take a look at the term frequencies in our second document. For I, it's going to be one occurrence divided by 5 words in a document. Love occurs 3 times divided by 5 words. And dogs occurs once divided by 5 words. If we only rely on term frequency in gauging what is important and what is not important, we're going to have a bad time. And that's because the most frequently occurring terms are words that might not be interesting to us at all. Words like the or of. We want to be able to discount these terms based on how commonly they are found, not just in the document, but also in the corpus at large. And that's where IDF comes in. Let's take a look at the formula for IDF. The numerator of IDF has the number of documents in the corpus in total. So in our pet sentiment corpus, we have 2 documents. And the denominator has the number of documents containing a particular term. So if more documents contain the term, IDF is going to become lower, and we're going to consider the term less interesting. We're now going to compute the IDFs for each unique term in our 2 documents. The first unique term is I. We have 2 documents in the corpus, and we also have 2 documents containing the term I. So the IDF for I is going to be log of 2 divided by 2, or log of 1, which equals to 0. For love, again, we have 2 documents in the corpus, 2 documents containing the term love. It's going to be also log of 2 over 2, which is 0. Then for cats, we have 2 documents in the corpus, but only 1 document containing the term cats. So it's going to be log of 2. And same for dogs. 2 documents in the corpus, 1 document containing the term dogs. So it's going to be a log of 2. Okay, so we got our TFs, we got our IDFs, and we're ready for the last step, which is to multiply TF by IDF. So for the term I in I love cats, we're going to multiply its TF, which is 1/3, by 0. and we're going to get 0. For love, also, the TF is 1/3. We're going to multiply it by the IDF of 0, and we're going to get 0. And for cats, the TF is 1/3. We're going to multiply it by the IDF for cats, which is a log of 2. And if you do this on the calculator, you'll get approximately 0.1. Let's do the same thing for the other document. So let's review. In I love cats, both I and love got a tf-idf of 0, meaning these are not important terms because they're so common in the corpus. And cats is an important term with a 0.1 tf-idf. Same story in the other document. I love dogs. I and love were very common, so their tf-idf ended up being 0, whereas dogs is the important term here with the tf-idf of 0.06. We're now going to write some code. And here's the problem we're going to try to solve. Given the body of an email, find the most interesting words in that email. We're going to expect the input emails to be generic and corporate, kind of like this one here from eBay. So here's a sample input email. This one is from eBay, and it's about the terms of agreement changing. And what we're going to have our script do is iterate over all the words in this email and compute a tf-idf score for each of those words. So the TF, term frequency, is going to be very simple. We're just going to look at how common that word is in the email. So for instance, the word dear, that only occurs once in the email. For IDF, if you recall, that's a measure of how common the word is in the corpus at large. We have not yet decided on the corpus. So we're looking for a corpus against which we're going to compare all the words in our input email to see how common they are. And we're looking for a publicly available corpus of emails, which really narrows it down because usually emails are not public, they're private. So something extraordinary has to happen for a bunch of emails to be released into a data set that we can just pick up and use. If we do a quick search on Kaggle, there's a few email data sets out there. We got the Enron email data set from the early 2000s, 358 megs. That's a lot of emails. We got Hillary Clinton's emails. We got customer support on Twitter, which is tweets. I'm going to go ahead and choose the Hillary Clinton emails. And a couple of reasons for that. It's a fairly recent data set. It came out in 2016. Also, the data in this corpus is in really nice, easy to use shape. We got a CSV file called emails.csv, where each row is an email, and we have the body of the email separated into its own column in the CSV file called extracted body text. And here's what some values of extracted body text look like. Okay, so I downloaded emails.csv into my project directory. And the first thing I'm going to do is write a script to pre-process the emails and generate IDF scores for each term in the corpus. We start off a script in Python with if name equals main. First thing in the script, we're going to read in the email corpus. So for that, I'm going to use the pandas package. So let's import the pandas package. So now I am reading in the emails from the CSV file. So that will set emails to be this whole data frame. But really the only thing that I'm interested in is the extracted body text column. So let me just grab this column. Now, some of the values in extracted body text are NA, not available. So what I'm going to do is filter out those records where extracted body text is missing. And you can do that easily in pandas by using this drop NA method. I'm just going to chain it to the rest of the pandas function call. The other thing we're going to do is convert the result of this to just a regular Python list. And you can do this with toList. So that should give us a list where each element in the list is the body text of an email. Let's see what one of the emails might look like. We can just print out the first one, run the script. Here's the first email in the corpus. So that looks good. Right now, each email in my list is a string, but what I want to be able to do is convert each one of those emails into a list of terms. And in natural language processing, this process of taking a document and splitting it up into pieces is called tokenization. So I'm going to tokenize this string, this document, into a list of terms. Tokenization can be a little tricky, so I'm actually going to use a library to help me out with this, the popular NLTK library. So first let me import the tokenizer. It's called word tokenize, and it'll read in the string and split it up into words. Let's see real quick what the output of the tokenization looks like. I'm going to tokenize just the first email here. Here's our tokenized output. A couple of things to notice. One is that we have punctuation. We're going to remove those because we don't need to compute IDF scores for punctuation. Looks like we have a mixture of uppercase and lowercase. We're going to lowercase everything. Also, we're going to remove the really common words like and more, because those are never going to be of any interest to us. They're called stop words. So we don't even need to compute IDF scores for those. Let's take them out. Okay, so now let me just get rid of this. I'm going to make a new method called getTerms. And what this will do is it will take an email as an input and lowercase the email. It's going to tokenize the email into words. We're also going to remove stop words and punctuation. So let's lowercase the email. That's going to be emailed to lower. Then we're going to tokenize the email. Tokens equals word tokenize email.lower. That's going to be our list of tokens. Now we're going to remove the stop words. To do that, first we need to get some stop words and some punctuation. The NLTK library has a built-in corpus for stop words. Let me show you what that looks like real quick. So these are the NLTK stop words. We're going to filter those out. I already imported the stop words corpus. So I'm going to start a new list called words to remove. And we'll start with the stop words. So that's the list that you just saw. But also I want to add any punctuation to the list. So in the string library, we have a string called punctuation containing the different punctuation characters that we'll want to remove. So I'm going to import this string. from string import punctuation, and then we're going to extend the words to remove list with punctuation, except that we're going to split up punctuation from a string into a list where each element is one character with punctuation. And then we're going to define a list of tokens that we'll have left after removing the ones that we want to remove. So that'll be T for T in tokens, if not T in words to remove. So that will iterate over tokens and keep just the tokens that are not in the words to remove list, and we'll return that. Actually, I'm going to make a quick tweak. We want the list of terms here to be unique, so I'm going to change tokens to a set of tokens, and that will get rid of any duplicate tokens in my list. Okay, so I have a method to extract the terms from an email. Now I'm going to run all of my emails through this method. So over in main, we'll do tokenized emails equals get terms of email for email in emails. And that's going to return me a list where each element is a list of terms in that email. Let's see what that looks like. Here is the list of tokenized emails. Here is a list representing the first email. And this is a list that contains all of our terms after the filtering. So I have my emails tokenized into terms. And the next step I'm going to take is to convert that into a dictionary of terms where each term is associated with which emails or documents it is found in. So for instance, the term discuss might be found in emails number 1, 3, and 4, and basketball might be found in documents 5 and 17. Once I have this dictionary, it will be very easy to compute how common each word is in the corpus. So that's going to take emails as an input. We're going to start off with an empty term doc dictionary. Let's just call it get term doc. We're going to iterate over our emails with indexes. For each email, we're going to iterate over the terms. And if the term already exists in our dictionary, then we're going to add the current document index to the set of document indexes associated with this term. And if it's not in a term doc dictionary, we will add a new entry with a set containing just the current index. And that's it. We're just going to return the term doc dictionary. Let's now get the term doc dictionary in main by calling the method that we just created with tokenized emails as a parameter. Now that we have our term document dictionary, we're ready to compute the IDF scores. So what we want to do is, instead of having a dictionary where the key is a term and the value is a set of documents, what we want the value to be is an IDF score. So something like 2.5 or 0.1 and so on. Let's now define a new method called compute IDFs. That's going to generate our IDF dictionary. And let's just recall the formula for IDF. It's log base 2 of corpus size divided by document frequency. And document frequency is just how many documents the term is found in. So this method will accept term doc as a parameter, and it will also take the corpus size as another parameter. We'll start off with an empty dictionary of IDFs, and we'll iterate over the terms in our dictionary. We're going to compute the document frequency, which is the number of documents that the term is found in. And now we're going to compute the IDF score for this term, which will be equal to math.log2 of corpus size divided by document frequency. And let's import math. And that's it. That's our IDF's dictionary. Let's add it back here in main. We're gonna compute IDFs, and we're passing in the term doc as well as the corpus size, which is nothing but the length of emails in our corpus. The last thing we need to do in this pre-processing script is actually save the results of our output. And for that, we can use the standard pickle library in Python. Let's import it. It's just an easy way to save Python objects into the file system. We'll open a pickle file for writing. Let's call it idf results.p. Let's call it idf file. We can do pickle dump, and we're going to dump IDFs into the IDF file. We're ready to generate our IDF dictionary as a pickle file. And here it is. So we have the script that will pre-process our corpus and generate IDF scores. And now we're going to work on a script that will actually calculate the full tf-idf score for a new previously unseen email. What we want to be able to do is run this script from the command line and pass it the file name of a previously unseen email. The script is going to read in the file, extract the terms, compute their tf-idfs, and return us the results in a JSON that looks something like this. So this will be the term, its tf-idf value, I'm just making these up, and we'll sort it by tf-idf so that the most important terms are listed first. Let's import argparse. If name equals main, we'll create a new instance of argparser, argument parser. We'll add an argument to get file name. This will be the file path of the email. Let's add a little help message here. Help message is going to be file path to input email. We'll parse the arguments. Now we're going to read the input email from the file. And now we're going to call a function that doesn't yet exist that will print the tf-idfs for all of the words in the input email. Let's define print tf-idfs. And actually, let's be a little more precise about what this will do. Print the list of terms and their corresponding tf-idf scores. So the first thing we'll do is we'll load our IDFs that we computed earlier from our pickle. So we'll need to import pickle. And it was called idf results.p. idfs equals idf pickle.read. So idfs is our dictionary where the key is a term and the value is its IDF score. And I'm just going to specify here that I'm opening up the file for binary reading. Now I'm going to tokenize my email into words just like I did in the pre-process script. So let's import the tokenizer. And I'm going to convert the email to lowercase. We're going to start off by calculating the TFs. So we have our list of tokens, which is a list, and we just want to add things up. So we have a total count for each term, how many times it occurs. And a simple way to do it would be to use the counter library, standard Python. Let's import that. So TFs is going to be counter of tokens. So we got our TFs, we got our IDFs, and now we can finally compute our tf-idfs. Let's iterate over each term in TFs. And its tf-idf will equal to its tf times its idf. There is a possibility that the term we're iterating over right now doesn't exist in the IDF dictionary. So let's check for that. Let's actually make a new dictionary called tf-idfs. We'll add the current term to the tf-idfs dictionary. Its value is going to be the tf-idf score. And that's it. We're done. We have our tf-idfs dictionary. So now we'll just print it out. And I'll actually use the counter library to sort the terms in the descending order by their tf-idf score. Yeah, one thing I messed up is reading in the pickle. That's not how you do it. It should be pickle.load and then the name of the pickle. So let's run our script. If I just run it without any argument, it should complain and tell me that the file name is required. So I'm going to give it eBay.txt, which is the email I showed you earlier from eBay. Here is the output. Most important term is eBay. Second most important term is user. Then we have agreement, then 2020, trademarks, then some kind of a weird character, ink, and so on. So not bad, not bad. Let's try another email real quick. Here's another email from AWS. They want me to take a survey. We'll run the script. And the top results are Amazon, survey, web, services, customer. Not bad also. The last thing I want to do is just a little bit of cleanup. You can see here what I'm getting is a list where each element in the list is a tuple. I'm just going to convert this data structure to a dictionary so that it's going to be easier to use down the road. So, and I'm going to give it a name instead of just printing it out. So let's say counter equals to all of this. I'm going to convert the counter to a dictionary and return it. And I'm also going to change this function to be called get tf-idfs, because instead of printing it, I'm just going to return the value down here. And in main, I'm going to say tf-idfs equals get tf-idfs, and then I can print them out just like this. So let's give it another run. And you can see that we get the same thing, but now as a dictionary. All right, so we wrote a couple of quick and dirty scripts to calculate the tf-idf scores and get those important words. And you can see tf-idf is a very simple yet very powerful technique. And it's used in a lot of areas of NLP. It's used for search and retrieval. It's used in machine learning to assign weights to different features. It's used in text mining and so on. I'm going to make a part 2 of this video where we'll take this script that we wrote and make a full-fledged API around it using AWS and serverless. So hit subscribe and you'll find out when this part 2 comes out. And thank you so much for tuning in.